What I want to talk about, though, is actually modeling craft. Okay, we talk about craft in our physical models. What makes a physical model well crafted?
Precision.
Precision, okay, which means clean cuts, okay. And what else?
Clean connections.
Clean connections, measurements are right. Yeah, things fit together really well. That's really the key, is that you have things, they're not like, you know, they don't have little holes in them, they don't have little gaps, things don't run over each other. It's a nice, clean, like, model. There's digital craft, okay? And precision in the digital model is just as important as in the physical model. And so a lot of the things I've been talking about are going to be addressing digital craft. Like, how do you get it to not have gaps in it? How do you get it to not have geometry that's overlapping or running into itself? If you do those kinds of things, you may say, well, I don't see them in the model. They look fine. But when you do the Make 2D especially, they're going to cause problems. The more precise it is in Rhino, the less work you have to do in Illustrator, the less work you have to do with it in other programs, right? It's just a cleaner, nicer model. Also, if you get good at this, when you get into fabrication, you're going to have to do less work cleaning that up as well. Okay, so figuring out digital craft is really important. So again, I want to talk about this. I want to talk about the elevation right now. So what I have is similar to what you guys would have, I hope, where you'd have an elevation drawing that you made in CAD, and it's, you know, could be scaffolded along with a plan drawing that you've made in CAD, right? And the two like align together, and you've got these things in your model. And the thing that we did with the kiosk was you guys made parts, and then you kind of lined them up with this. Okay, we're going to do something a little bit different. We're going to use this to create the drawing like right on the scaffold. Okay. So what I do, these will be on different layers, but I'm going to go ahead and lock these together. So now I've just got them, you know, arranged for a scaffold. I've got my end snaps turned on. I'm going to turn off all the snaps that I don't need so I don't accidentally snap the stuff. Okay? And there's different techniques, and I've seen some of you guys use these techniques, so I want to start to talk about these. A technique that I see people do often is if you have this kind of scaffold, they'll take a box and they'll just begin, you know, snapping to things. You know, snap to the plan, snap to the elevation, you know, snap to the plan, you know, snap to the thing, snap to it, and then kind of going down here, snapping to the elevation. Then things get a little bit tricky, but you might start at the top and snap to the edges, and then snap down here, and do the same thing for the door lintel. Okay, what's wrong with that? It's pretty good.
Midpoint seams that you're going to snap to.
You got seams in it. And if you're building, if that's really meant to read as a solid wall, right, you go into Make 2D and you've got all those like seams running down that piece. Okay, so again, you get the geometry, and you know if you probably, you know, rendered it or whatever, it looks pretty good, right? But the geometry's not quite right. Now you might do this if the depth of this is like changing slightly, or these are pulling out, pulling in, like then you're going to want those to read differently. But if they're meant to read as one thing, they should read as one thing. Okay?
You can combine them, right?
No.
You wouldn't make like the whole thing?
If you boolean them together, they're not inside each other. They're next to each other. And if you boolean it, it's still going to preserve that. It's still going to preserve those edges like that. It fell right into my trap. Okay? Yeah, you could say, just boolean all these things together, right? Happy day, okay? But no, because it's going to have all those extra points, all those extra lines. The boolean operation doesn't get rid of all that extra junk. It just fuses them together as you know, maybe like a group, okay?
So it's just like the grouping that ARCH has, like points of all the lines and stuff, yeah, it's exactly the same.
Kind of, yeah, yeah. But again, it's not clean. You know, the solution to this is actually fairly simple, okay? Delete this. Actually, let's not hide it. One of the things I'm going to talk about today is that, okay, a principle is that you've got these drawings from CAD. And one of the things I showed you guys a couple weeks ago that makes sense in Rhino is that when you extrude something, a lot of modeling is extrusion. And when you extrude something that has another shape inside of it, and you cap it, you know, then you get like a hole in it, okay? Now you could go in and make the solid and then boolean the thing out and get the hole, but I find this to be a lot easier. You have the shapes. So you could say, well, I've got these CAD files and they've got these, so I just extrude the elevation and I'm done, you know? But there's things that can go wrong with that. First of all, your CAD files by and large are probably not that clean. You probably didn't join all the lines together as polylines. There are probably lines left over from different operations. There may be two lines hiding in the same place as a line. There may be a half line inside of a whole line. Like you don't know what that, what's going to happen in there. So what I do is I would go to that elevation view and I would turn off the plans or whatever, turn on, like project so that I'm flat. And then you could go in, and I would actually retrace the geometry. And the reason for this is that you actually know what you're getting. Everything that you do, you know that that's a joined, shape. You only trace the forms that you want. So if you are getting a push and pull, you're actually tracing the areas that get pushed and pulled. Okay. So you're going to go ahead and make that operation, and then go ahead and knock out, anything that you have for windows. This is very simplified, but this may be all the level of detail you need. Once you've got that, you take those two sets and you extrude them, and then you snap to the, I turn off project here, snap to the plan, and now you've got a solid block, okay? And you do this, you like repeat this for all, like many sides of your building that you have, like for all of your elevations, okay? Now, you might be saying, I don't have elevations for all the sides of my building. Probably don't. I'll show you a technique for that in a second. But this is the kind of principle, though, is you really do want to work in the orthogonal view and then use the other views to kind of give you the extrusion depth. To do your floor plates, you would do a plan view and then extrude it into section because you're gonna get the depth of it from the section. Okay, so you usually have to use more than one view in order to get what you want. Okay. So that's clean craft. Like that's a nice wedge of your building. That's gonna produce the lines you want. Okay. Brings up another point. I've got this kind of mullion here, and I actually am really reading these windows as two different things. You might ask yourself, do I want to add that much detail, to my model? If you wanted to do something like that, you could always basically take the cross section of it. So, oops, go top view. So you take this, and then go to the front view, and it's there. It's a tiny thing there, and then you move it. And I'm gonna move it in the midpoint to here, and then go back to perspective view. And then extrude that, and then snap it. Okay, so I have to switch between multiple views because I need to make sure of what I'm doing. So I draw the section of the tube in the top view, or of like my mullion. Then I move it up in the front view, and then I extrude it in perspective to get a sense of it. Because I can snap to. This lets me snap to the elevation. So then I can add that detail back, and actually. I might need to, if it gets moved out of place, which is my problem here, I can move it in top view. I might actually project it. So anyway, that's where your snaps are going to come in handy. So just, I didn't do project. Okay. That preserves the plane it's in. Okay. Yeah. Moral of the story is, you have to get comfortable working in multiple viewports in order to be able to get things oriented to each other correctly, in order to start building up your model. I don't think that you necessarily want to model the glass in this, just in the sense that you guys don't model glass in your physical models. It's just going to add more geometry to it. You want these to read as openings, I think, for now. Unless it's just important to read that facade as like a solid. Then you might just put a plane in those. That works okay too. But just really simple. Like you don't need to model every door. You don't need to model if there are columns in this wall. If you're never going to see them, if you're never going to see the mullions, that's this kind of glass detail. Don't model it. Okay. If you're never going to see it at that level of detail, it doesn't matter. Okay. So just think and plan before you model, like what level of detail you're going to be working at, and plan ahead. Like you have to think about these operations that you're going to make. Question?
Regarding the structure, if you do see it in the exterior elevation, but you're not meant to see it on the interior,
You model the parts you see. That's actually a good rule of thumb for anything in the like model. If you are never going to go inside of a building and you're never going to see inside of it, like don't model the inside of the building, just model the outside of the building. You know, like again, it's not a one-to-one model of your building. It's you're modeling the stuff that you want to see. You're modeling the stuff that you're going to draw. Okay, so if you're going to see the outside, you model just the outside surface of it, and then you don't even model like the back of it, or you don't model the part that's embedded in the wall. Right? You're never going to see it. Okay. If you're going to diagram it, maybe you do it, but again, just don't take on anything that's not going to be visible. Eve?
You accidentally somehow close that bar with all the tools on Rhino. How do you open it?
I think you can just go up to Tools, Options, and I think there's a setting here to open up your toolbar again. Otherwise, you can like get rid of your preferences file and restart it. That's the kind of thing you can Google. I think there's an option here though. You know what? Reset toolbars. There you go.
Are you talking about the properties thing?
The properties is F3.
I'm talking about like the lines and all those
Yeah.
different things.
Reset toolbar. I think there's a setting under options too. Anyway, yeah. Okay, so there's that. I'm gonna show you using Thomas's model. I just want to quickly, run through this kind of process. So again, you would take all your drawings from AutoCAD and just like in your kiosk model, and you'd arrange them with each other, and you would export them to a DWG that's an old DWG, like an AutoCAD 2000 or a DXF, of a very old vintage, so that you don't miss any information. Open that up inside of Rhino, making sure to pay attention to the scale of that file. Then you start arranging your scaffold. So this is all of the stuff that we did before. So I have a couple of sections. I have all my plans. Everything's on the right level, right? So you have your scaffold. Then you make sure that things are on layers. Then you lock those things. Okay, this is the model we did when we first studied Rhino here. This is our camera model. Okay. So this is the process that I had for all these pieces. And again, you have to kind of plan ahead. Like don't turn everything on if you don't need it, right? You might begin by looking at modeling the ground floor plane. And remember, I said that you want to actually trace things. You don't just want to extrude things because again, you don't know how the lines are grouped together. You don't have to go through painstakingly and use the polyline tool to grab every single edge of something. Okay, you can do things like you can draw rectangles and things, and use regulating lines just like you would in AutoCAD. So you just kind of draw over things that you need to, and then you can always do trims and things. Okay. So I can trim away. And then when you're done, you join them together. Okay, so you don't just go through and snap to everything. You can do some of these quick operations like that. And you begin to understand, again, you don't necessarily want to render the entire thing as a big flat surface of tofu. You might want to cut away places where it joins things. Because again, it's not just this is part of the craft. You're going to have nice intersections where the things start to join. You have to be kind of careful about how you do that. But I just want to call that to your attention. That's going to give you a nice clean edge when you do Make 2D. So you could do this. Then you can extrude this curve. Actually, this one, since it's the ground, could just be a plane. You can make it a planar surface. Okay. And that's going to give you just that. Since it's the ground. On other floors, I'll use a section to give you the depth of it. Or you might need to extrude this section in order to give you pieces of your floor. If you have anything going on with any of the overhead beams, you might actually have to work in section in order to start developing this. And there it might be in pieces. It just might be the way it is. Okay. Then, like I said, when I had the elevation, I could trace pieces of the elevation. And I could do the same technique. I could do the lines, or I could do the trim that I showed you. So I've got that piece. Again, well, on that I use project, but if you mess that up, you can always go ahead and move it in 3D. There we go. Actually, I was looking at it from the wrong view. That's why. Okay, and then you can go in and you could turn on the ground floor plan to get the thickness of it. Or actually, it's probably the second floor, but first floor. And just begin working that way through this. With the columns, they're usually simple extrusions. Stairs, you want to extrude in section, right? You want to trace the outline and extrude that. Actually, trace the outline in section, extrude it in plan. And then the last thing I want to talk about is what happens when you don't have enough information for one of your elevations. In my set of drawings, I don't have, this elevation. If you guys recall, open up my model here. I've actually got. So I've got this piece right here in the elevation. I don't have that elevation. So how would I actually get that? And what I'm going to do is I'm going to go ahead and make sure to just turn off the things I need and the things I want to make sure to turn on the things I need, turn off things I don't need. And so the first thing I'm going to do is actually just mass it out. So here I am actually going to use boxes to mass out the elevation. So I know I have this line in the ground, and I know that at least goes up to the first story. So I can make a box out of that, and I can mass that up to, that first like floor plate on the first floor. Actually, I'm gonna extrude that a bit more. So just take a box and extrude it up to this floor. Okay, so I turn that on. Then I'm gonna go up. I'm gonna hide this. Then I'm gonna go to the next level, and I can begin extruding, those pieces up. So make my box, take it to the edge of the window. So this is, again, the technique that I said kind of not to do. This actually applies. So I'm using the 2 floors to begin to mass those out. And then again, taking this. And I take my section, you guys see this? Take my section and I snap to it to get the window. Start from the top. Use the section to get the window height. Okay? So I do that. And eventually I'm going to get like all those boxes for the whole thing. So I'm sort of like reverse engineering that elevation from a collection of the plans and the sections that I have. Okay? And then I get the elevation. Then what I'm going to do is look at that in the proper orientation, and then using my project snaps, I'm going to go ahead and actually just draw the window lines that I need. So I'm just drawing. I'm drawing my lines. So I'm using this as a scaffold to create my well-crafted elevation. So now I've got that. Then I can go ahead and wipe these out. And then once I get my drawings back, I can take this, move it back into position, and now I've got my clean elevation that I could extrude with my plans. Okay, so that's how I did that. So you can, using the magic of orthographic, like when you have the orthographic drawings that are actually aligned with each other, you can get any one of the drawings that you're missing from your plans. Okay, this is where like working in 3D is actually like pretty useful. Okay, so that makes it really clean instead of all the boxes and things. Any questions about that stuff?
Is there a way to give a 3D object grips so you can stretch it in one dimension?
No. In an AutoCAD, you can grab things and stretch them. In Rhinoceros, at least in version 4, there really isn't. I thought I talked about this before. There's a hacky way to do it, in that you can take some kind of like geometry that you have. You can explode it, turn on the control points for it, and then you can move them. And then you turn the points off, and then you grab all the surfaces, and then you join them back together again. That's the really terrible way of stretching things, but yes, that's how you do it. You can also do what's called like an n-dimensional scale. So you can scale things in the x or the y or the z, but that only works with things that are really, really planar. It doesn't work the way you probably expect it to, okay? So long answer, yes, short answer, no, right? Just draw it right the first time, pretty much. You're working from your 2D drawings. You're not really doing a lot of development in this. This is really to represent what you've already done orthographically and with your physical models, okay? Any other questions about this? Okay, so this, again, this is something that you'll kind of get used to, but you'll use this technique more than the kiosk technique moving on. Like, you'll be doing a lot of your design, at least starting some of it out in 2D, and then actually developing it in 3D with this kind of extrusion technique. Okay, that's it.
In the example you showed us where you did the mullion,
Mm-hmm.
it was just like, it looked like a column. Like, do you recommend just doing something like that? Say you had like a C.
Again, how far away are you going to view it? Does it read like a C or does it read like a column?
Yeah. So maybe if you're doing a detail, you want us to do that, but in the
It'd be the difference between 8 points and 16 points, right? And then when you repeat that over 100 millions, it's going to really increase the size of your model. So unless you have a view and you're looking at it and it's a really important thing, if it's going to read like a stick, just make a stick. But if you're going to do a detail of it, right, then just totally go nuts because you're going to have that nice zoomed in, like view of it. You might even have one on a layer that you can swap out for like a particular view. Okay? Yeah. Just you have to really think ahead about your design. You have to design the model as much as you design anything else. Okay? You say like design the drawing, you design the model. Good. Any other thoughts? Jen and Josie, anything? Does that cover it? All right. Okay. If you guys have any more specific questions, maybe I can talk to you about it. But hopefully this kind of fills the gap between things and helps you guys figure out how to make your models. Some of your classmates have some experience. Some of the upper year students do. Use them. Okay? Good luck.